We're going to take a look at section 8.1 and 8.2 on confidence intervals to estimate a population mean. And to get us started, to get us an idea of thinking about what is a confidence interval and why we care about it and how to calculate it, let me give you a visual of what that looks like. And we're currently, as I make this video, in the COVID-19 crisis now going around the country. And I want to show you a picture. This is a website, famous stats website, 538, that does statistics on all these different topics in our country. And what they are doing at this time as I make this video is talk to 18 or 19 of the top infectious disease experts in the country, and ask them this question: what is the smallest and most likely and largest number of total cases that COVID tracking project will report on April 12th, right? And so being able to get a prediction, and this is 3 days prior, sorry, this is April 6th to 7th, so this is 6 to 5 days prior to that date. And you can see each expert, you'll see the middle number is their likely estimate, and then you will see their range, their interval range, right? And they're basing off some level of confidence. They think it's going to be between this and this. And important, I think, to look at this is you'll see even experts have a wide variety of answers in terms of what they're looking at. So we're looking here as a distribution, right, from the experts here, but you will see this range of values. Some think it's going to be less than 500 all the way up to over 2 million, and that's just in 6 or 7 days they're trying to project out. That's what we're going to look at here, this idea of a confidence interval, because we're looking at ways to estimate what the value is actually going to be, which we don't know yet. Just like we're trying to estimate values of a population, we don't know how many cases they're going to be in the population. It's hard to project that, and you can see a wide variety, a lot of variance within that. Important to understand that, especially as you're living, and if you're living COVID-19 now, right, and experiencing, look at the wide variety of answers, right? But in general, everyone's kind of within the same place here, being able to predict around 660 in the next few days. We'll see when it's April 12th. So that's what we're looking at here. And to get us going, we have to go back to the central limit theorem and go back to this idea of a sampling distribution for the population. Mean a sampling distribution, right? When we take samples from a population, you will see again the distribution. If you take a sample from the population, the sample means are going to be distributed across in a normal distribution, right? Some will be very close to the actual mean, which is mu, and some are going to be a little further off, but most are going to be very close. And that's the idea, right? That we talked about in the previous section. The distribution of sample means, right, is normal under these conditions here, and so we did that in previous sections here. Something to think about, just to think as we look at this example here, estimate the average number of hours students in your class work per week, right? So just think about that. If we were in class, we could have a full discussion on that and how you would come with that estimate, similar to that COVID-19 example, a low estimate, a high estimate, and what you think the actual estimate is. As we think about this here, let's look at the problem that emerges from this. Suppose that students at a community college, right, work 24.7 on average with a standard deviation of 9.1. Now, if you randomly sampled 52 students at the school and asked how many hours they are working, right, what do you think the mean would be, right? And so that's our question. What's the probability that the mean of 52 students is greater than 25? What would we think about that? How would we calculate that? You'd get this answer here. Remember, this is the previous section of what we had to do. Now, in order to build confidence intervals, right, to come up with our statistically low and high estimates, which that's what we do. We give you formulas to do these low and high estimates as opposed to just having you guess them, right? We use this idea of this sampling distributions to help us come up with those estimates, right? The adjusted standard deviations, the standard error, right, or the standard deviation of the means to do that. And then you can see here, if we were going to find a usual range of values right under these conditions, what would they be? Remember, it's the mean plus 2 standard deviations, but we're using the adjusted standard deviation because we're talking about a sampling distribution. So you would see the usual range of values a student would work is somewhere between 22 to 27 hours.